Hi, this is Mrs. Downey, and we are going to do the Algebra 2, Chapter 11 study guide over probability and statistics. This is the first part of the chapter through the first 4 lessons. We started off class by turning in their assignment from yesterday, and then we did some journal work today, starting on some literacy practice. What have you learned the most in this unit, and what do you still find confusing? And hopefully by the end of this test, we will not have that confusion anymore. Our first problem on the study guide says a yogurt shop offers 5 different flavors of frozen yogurt and 11 different toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? Well, we know that the fundamental counting principle, Fundamental counting principle says the method of using multiplication to count the number of ways certain things can happen. So how many ways can this combination happen? Well, we have 5 different flavors and we have 11 different toppings. So what we do is we just multiply, use multiplication. So 5 times 11 is 55. We have 55 different combinations for our yogurt and toppings. Number 2 says, in how many different orders can you line up 4 cards on a table? So if I have 4 cards laid out there, how many ways can I line this up? Well, we know that to do this, it's going to be a factorial. N factorial. And N is the number of items that we have. How many different items do we have? We have 4 different items. So to get our answer, we're going to do 4 factorial, which is equal to 4 times 3 times 2 times 1, and that becomes 12 times 2 times 1. So our final answer is 24. Number 3 says there are 10 students participating in a spelling bee. In how many ways can the students who go first, second, and third in the bee be chosen? So how many different ways can we choose first, second, and third place? So we want to find out, is this a permutation or a combination? And well, I let the kids choose. If you say it's a combination, nope. If it's a permutation, yes. So this is a permutation. That means we're going to use the formula with the P in it. The NPR. N being the number of items, R being the rate. So what we're going to do is use this formula, and we need to pick out our N and our R. So N, the number of items, we've got 10 students, so that's our N. And R, our rate, well, we've got a first, a second, and a third. So we have 3 of those. So N is 10, and R is 3. So now we're going to fill in our formula, which is equal to 10 factorial over 10 minus 3 factorial, which is equal to 10 factorial over 7 factorial. Well, we can simplify this. Whoops. So 10 factorial over 7 factorial can be simplified by rewriting 10 in terms of 7 factorial. So we know that 10 factorial is just 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm going to leave this in terms of 7 factorial because I've got that in my denominator and I can cancel those out. Alright, so that leaves us with 10 times 9 times 8. Well, 9 times 8 is 72. 72 times 10 is 720. So my final answer is there's 720 possible ways to get first, second, and third with our 10 students. Number 4 says, what is the formula for NCR? Or evaluate 8 C6. So that means that our N is 8 and our R is 6. So what is that formula for NCR? And it is this one. N factorial over R factorial times the factorial difference of N and R. So our N, I stated, is 8 and our R is 6. So let's put it to use now here with this formula. So I'm going to have 8 factorial over R factorial, which is 6, times N minus R, well that's 8 minus 6, which is 2 factorial. So we can rewrite 8 factorial in terms of 6 factorial. We want to get rid of that largest factorial in the denominator. So rewrite your numerator in terms of that excuse me, factorial that you want to get rid of. So it's going to be 8 times 7 times 6 factorial over 6 factorial times 2 factorial. The 6 factorials cancel out, and that leaves me with 8 times 7, which is 56, over 2 factorial, which is 2 times 1, which is 2. Excuse me. So it's 56 over 2, which is 28. And that's our answer. Okay, our next problem says Lynn and Don tossed a coin 40 times and got heads 18 times. What's the experimental probability of tossing heads using Lynn and Don's results? So they flipped it 40 times. Out of that 40 times, they got 18 heads. So that means they got 18 out of 40 were heads. And that's all we have to do. Let's just simplify our answer, dividing both by 2, simplifying to 9/20, and that means 9 out of every 20 coins they flip, probability that they're going to have a head. Number 6 says a spinner is numbered from 1 through 10, with each number equally likely to occur. What's the probability of obtaining a number less than 2 or greater than 6 in a single spin? So our qualifications here are less than 2 or greater than 6. Well, we know we have 10 total spaces on this board. We have 10 total, that's our denominator. But what is it that we're likely to land on? What do we want? What are we desiring? We are desiring that it be less than the number 2. Well, we have one thing less than the number 2. We have one thing. And then how many things do we have greater than the number 6? Well, there's our number 6. So 7, 8, 9, and 10. We have 4 things greater than the number 6. So we have a chance, 5 different chances to land on something less than 2 or greater than 6 out of 10 spaces. So it's 5 in 10 chance, which is 1/2. And that's our answer. This says if the dart hits the target at random, what's the probability that it will land in the shaded region? Well, the shaded region is a small circle. That's where we want to do. So our desirable spot to hit is that center region, which is a circle. So it's pi r squared, and our radius for the small circle is 2. So it's pi 2 squared all over what we can possibly hit. The large circle is pi, and our radius for that is 10 squared. So it becomes 4 pi over 100 pi. Our pi's cancel out, and we can simplify 4 100ths to 1/25, and that's our answer. Our next problem says suppose Q and R are independent events. Find the probability of Q and R, where P of Q is 0.45 and P of R is 0.74. So we need to think about what the and means, and it means to multiply. So when we do this, we're just going to multiply the two events together. So 0.45 times 0.74. And when you multiply those together, you get a 0.333.